All right, so in this video we are graphing linear equations. If we look at example 1, it says graph the equation in slope-intercept form. So they give us the equation, and we know we want to graph it in slope-intercept form, which is y is equal to mx plus b. The first thing you want to do is identify your slope. We know that our slope is 2 over 3 because it's the coefficient to x. So the slope is 2/3. We know that this is our rise over our run. From here we identify our y-intercept. And our y-intercept, if we look at our equation, is -4. So if we look at step 1, it tells us to plot the y-intercept, and they want us to plot it as an ordered pair. Our ordered pair for the y-intercept is 0b. So if I were to write the y-intercept for this equation, I would write it as 0, -4. If we turn over to our graph, we'll talk about the characteristics of our graph really quick. We know that that upper right quadrant is our quadrant 1. We know that our x values and our y values in quadrant 1 are positive. If we move counterclockwise and look at quadrant 2, we know that the x values are negative and our y values are positive. If we move down to that lower left quadrant, we know that it is quadrant 3. And the x values are negative and the y values are negative. That last quadrant is quadrant 4. In quadrant 4, our x values are positive and our y values are negative. From here, we go back to our steps, and they told us to plot the y-intercept. Our y-intercept for this equation is 0, -4. So I plot the point 0, -4. If we move to the graph, we have 0 on the x-axis, and we move down to -4, and we plot our point. From here, the steps say to use the slope to plot the points. And we know that our slope is 2 over 3. What we need to keep in mind is that if the slope is positive, we know that we need to go up and then right. If the slope is negative, we want to go down and then right. So using the slope from the y-intercept, we want to rise 2 units. So we rise 2 units. We know that our run is 3. 1, 2, 3. And we have our additional point. From there, we can create another point. If we go from this point, we rise 2, 1, 2, and run 3. 1, 2, 3. We can also put points on the other side of the y-intercept. To do this, we have to go in the opposite direction. Instead of going up and right, we would go down and left. For instance, if I were trying to get from this point to this point, I would go down 2 units and then left 3 units. So if I do that again, I go down 2 and then left 3. 1, 2, 3. We'd have a point here. Our last step simply says to connect the points with a straight line. So here I'm going to connect the dots. Please keep in mind when you draw your lines that you want to extend them all the way to the edge of your graph and then put arrows on both ends. Lastly, you want to go ahead and write the equation of the line on the line. So we have y is equal to 2/3 x -4. And this is example 1. If we move down on the notes, notice that they ask a question. They want to know, is the point 12, 4 on the line? So if we look at this point, we know that 12 is our x and 4 is our y. If we look at our graph, we notice that our graph only goes out to 6. Another way to determine whether or not a point is on a line, if you cannot find it on the graph, is to plug it into the equation. So here our given equation was y is equal to 2/3 x minus 4. So I go ahead and write down the equation. And I want to plug the point into the equation and determine whether or not it makes it true. So in place of y, I'm going to write 4, because that's what y was equal to. And then we have our slope, which was 2/3, and this is going to be times x, and x is 12 minus 4. If I simplify, I get 4 is equal to, and here we have 2 times 12 gives us 24, divided by 3 would be 8, minus 4, and we find that 4 is equal to 4. Notice that because the point makes the equation true, we know that it is on the line. So we write, yes, this point is on the line, as it makes the equation true. I would tell you that any point on the line is a solution to that equation. So over here, when they ask you, is the point 6, -6 a solution to the equation, we have to see if this point is on the line. And this point, we can actually look at the graph. If we look at 6, -6, we would have a point somewhere down here. And we can clearly see that this point is not on the line, so it is not a solution. But how do I prove that algebraically? So I want to plug this point into the given equation, which was y is equal to 2/3 x minus 4. We know this is our x and this is our y. If I plug that into the equation, I would have -6 is equal to 2/3 times 6 minus 4. We get -6 is equal to, and here we need to multiply that fraction times the whole number, so we make the whole number into a fraction and multiply straight across. 2 times 6 is 12, divided by 3 gives me 4. And we finish the equation, which was minus 4. We get -6 is equal to 0. And we know that this is not true. So we know that this point is not a solution. If we continue down, you guys have a checkpoint that you guys need to complete. If you will, go ahead and graph this equation, y is equal to -1/2 x plus 3. Identify the slope, and then identify your y-intercept. Please identify that y-intercept as an ordered pair. If we move on to example 2, they tell us they want us to graph the equation in standard form. So you guys have a new vocabulary term. It says that the standard form of a linear equation is the form ax plus by is equal to c. If we look at the slope-intercept form, we have y is equal to mx plus b. We notice that with the standard form, our x and y are on the same side of that equal sign. So if you are given an equation with your x and y on the same side, you know that your equation is in standard form, where a and b are coefficients and c is your constant. All right, so they want us to graph this equation, and we have some steps. Step 1 says solve for y. So we're going to rewrite our equation. It's 4x minus 6y is equal to 12. And the first step said to solve for y. So I need to isolate this variable. The first step would be to move the 4x. And since it's positive, I want to subtract 4x from both sides. So on the left-hand side, I get a negative 6y is equal to, and remember we want to put that variable in front. So we have a negative 4x plus 12. From here, I'm still trying to isolate y, so I need to divide by that negative 6, keeping in mind that what I do on one side, I have to do to every term on the other side. So therefore, y is going to be equal to, because I have a negative over a negative, I know that my slope is going to be positive, and I want to reduce it. So I get 2 over 3x, and 12 divided by a negative 6 is going to give me a negative 2. So my equation in slope-intercept form is y is equal to this 2/3 x minus 2. From here, our steps say to graph the line using the steps for slope-intercept form. So we need to identify our slope, and our slope is 2 over 3. We know that our rise is 2 and our run is 3. If we identify our y-intercept as an ordered pair, we know it is 0b, so my y-intercept has to be 0, negative 2, because the y-intercept is the point 0, b, whatever b is in your equation. From here, I want to plot my y-intercept, and my y-intercept is at 0, negative 2. So I go 0, negative 2, and I plot my point. From there, I want to use my rise over run, and this slope is positive, so I know I'm going up 2 and right 3. From my y-intercept, I go up 2, 1, 2, and right 3, 1, 2, 3. And I can do that again. From this point, I go up 2, 1, 2, and right 3, 1, 2, 3. And there's my additional point. I can also put points on the other side of the y-intercept. I would just go in the opposite direction. So instead of going up 2, I need to go down 2. I go down 2 and then left 3. 1, 2, 3. And now I can go ahead and connect the points. For each line, please go ahead and plot at least 3 or 4 points. So I draw my line and I extend it to the edge of my coordinate plane, making sure that I put arrows on both ends. And then lastly, I write the equation on the line. So y is equal to the 2/3 x minus 2. And we've graphed the line. If we continue on in the notes, notice you guys have a checkpoint. They want you to graph the following equation. Remember, solve for y, identify your slope and y-intercept, and then graph the line. In our last example, we are talking about using the slope-intercept formula when solving word problems. And it tells you that you want to use this formula when they give you a rate and a starting amount. So we're looking at the slope-intercept formula, and we need to talk about what the parts mean. So we know that our slope is going to tell us the rate of change. So it tells the rate of change. And the key word we want to look for is per. So we want to look for the word per. For our y-intercept, or our b, we know that it tells us that one-time amount. And we know this is our constant. It's that fixed amount, the amount that does not change. If we look at the given word problem, It says that Susan is going to order CDs from an online music store. The store charges $12 per CD.